So just like that, we also have waves, and waves are similar to that. So conduction was in solids only, and it was when heat is traveling from one point to another. Just like that, waves are another way of transmitting energy, but this energy is not heat energy. Like it can be heat energy, but it doesn't have to be. And energy is transferred from a point where there is high energy to a point where there is low energy. And this point where there is high energy, in fact, the one that is emanating that energy, we call it the source. So there's a source that gives off energy. And what it does is that it vibrates or it moves. And that way it disturbs the particles around it. And those particles also move, and they disturb the particles around them. And eventually it creates a whole wave where energy is transferred from one point, disturbing the next, disturbing the next, disturbing the next. So again, like a domino, this travels and goes from the source away from the source towards the other thing. Now, usually it happens in all directions. For example, if you have a source that's going like this, so it will be radially outwards. So the energy is going to go out from the source. Similarly, if there's a source which is like this, so it is possible that wave will be generated like this, like this, like this, like this, in both the directions. All right. So energy is transmitted like that. Again, this was your source. If the source starts to move itself, then energy is also transmitted that way. So for example, if this source started towards this, so it is possible that I will have new patterns where this will be the norm. So it will be like this. So it will be closer on this side than the other. But we'll talk about this when we study this in detail. So that's a wave. So if you were to define what a wave is, so you'll simply say that it is when energy is transferred from one point to another without transfer of medium. So the thing that is transferring this energy, that is not traveling. That doesn't go from one point to another. It is just that the energy is transmitted. And that's a pretty interesting thing because it's like a message being sent, but the carrier is not going with the message. So that's exactly how this energy is transmitted through waves. So wave का समझ आ गया? Wave is that one particle disturbs the next, disturbs the next, disturbs the next, and that way it keeps on moving. ठीक है? तो हमारे पास ये wave होगी. अच्छा, अब इनको हम कहते हैं mechanical waves because they all depend on disturbing something else. There's some movement that the source has to do for the wave to transmit. Not all waves are mechanical. Like you can transmit energy as wave without having to move the source. So there are electromagnetic waves that don't really have to transmit. The source doesn't have to really move. So sun doesn't have to move to give energy away. It uses electromagnetic waves to do that. So there's the mechanical wave where the source has to move. And there's the electromagnetic wave where the source does not have to move. Okay, so there's some disturbance of the source that causes the medium to travel. So this requires medium, which means that the source must disturb some particles, which will then disturb some other particles, and that way energy is transmitted. This does not require medium because the source doesn't have to disturb a medium. In fact, the energy, the wave itself has its own particles. So this doesn't have its own particles. It's using some other particles to travel. So for example, you can have waves in water. So energy is riding on top of water droplets. But in electromagnetic waves, that doesn't happen. So mechanical waves require some external medium to travel. But electromagnetic waves have their own particles to travel. So those particles are photons. Okay. So they instead rely on photons. But mechanical waves rely on whatever medium they're in. What that means is that if the particles in the medium are close together, then wave will travel faster because the disturbance will travel faster. But if the particles are far apart, wave will be slowed down. And that's exactly what happens. So the speed of a mechanical wave depends on medium's density. So if you have a higher a medium that is more dense, then it is possible that particles will travel, the energy will travel faster. and also on another a couple of other factors like are the particles free, how strong are the forces, those kind of things also figure this speed depends on that as well. But in this one, energy is traveling on its own photons, so speed is fixed in any medium. So if it's traveling in air, it doesn't have to rely on air being more dense or less dense. The speed in air will be roughly the same. Also, the speed in a mechanical wave also depends on the source generating it and all that. So in electromagnetic waves don't entirely disregard the medium. थोड़ा सा medium का फर्क तो होता है उसके ऊपर definitely, but mainly इसके nature का फर्क होता है. It's not entirely dependent on the medium. But mechanical waves depend on the medium. So अगर medium बिल्कुल ही नहीं होगा तो वो travel कर ही नहीं सकती, इसकी speed zero हो जाएगी. But that doesn't happen in the electromagnetic waves. Okay. Also, in mechanical waves, frequency is fixed because frequency depends on source. So I'll briefly explain what frequency is. So frequency is how many waves are coming out per second. So if you have 5 waves coming per second, we'll call it 5 hertz. And if you have 500, we'll call it 500 hertz. If you have 5,000, it will be 5 kilohertz. Okay. So that's the frequency. And it all depends on how strongly or how fast this source is vibrating. So if the source is vibrating 5,000 times a second, the wave will have 5 kilohertz. But electromagnetic waves don't really, their frequency does not depend on the source. So same source can give you multiple kinds of frequency. But what is fixed is velocity. So there, over here, mechanical waves have frequency fixed, which depends on the source. But in electromagnetic waves, frequency does not depend on the source. In fact, frequency is directly related to wavelength, inversely related to wavelength, sorry. Okay, so because they have speed that is fixed, their frequency changes if their wavelength changes. So the higher the wavelength, the lower the frequency, and higher the frequency, lower the wavelength. So in mechanical waves, speed changes if the medium changes, and frequency doesn't adjust according to that. In electromagnetic waves, frequency doesn't adjust depending on the source. In mechanical waves, frequency does not adjust because वो fixed होती है. In electromagnetic waves, speed थोड़ी बहुत change हो सकती है, वो constant रहती है, frequency और wavelength दोनों को adjust होना पड़ेगा फिर उसके लिए. ठीक है? तो थोड़ी सी main ideas about electromagnetic and mechanical. The division isn't as rigid. ऐसा नहीं होता कि अगर एक चीज electromagnetic कर रही है तो mechanical बिल्कुल ही वो नहीं करेगी, ऐसा नहीं होता. It's just a few facts that you need to remember when you are differentiating between them. Okay, so that is what the two main kinds of waves are. अच्छा, एक और तरह से wave को हम describe करते हैं. That depends on the movement of source. So how is the wave traveling? So one way of figuring that out is कि अगर आपका source जो है वो ऐसे आगे पीछे move कर रहा है, तो आपका if there is another particle that is vibrating, so वो भी आगे पीछे move करेगा, because ये उसको hit करेगा, वो और आगे वाले को hit करेगा, वो आगे जाएगा, वो आगे जाएगा, उतनी देर में ये पीछे आ जाएगा, ये भी पीछे आ जाएगा, वो फिर उसको hit करेगा, and that way energy is traveled. Where is the energy going? Towards this direction. That is the traveling direction of energy. And how is the particle moving? It is moving parallel to energy, right? The movement, so this arrow is parallel to this transfer of energy. So this is parallel to transfer of energy. So movement of particle is parallel to movement or direction of energy. So if this happens, we call this wave a longitudinal wave. So we say it's a longitudinal wave if the particles are traveling parallel to where that wave is going. So an example of that would be sound wave. So for example, you have a speaker. So speaker has this paper cone. ठीक है? उसमें एक paper cone होती है. There's this electric circuit that pushes the paper cone forward or backward. तो वो आगे पीछे move कर दिया. That way it pushes the air particles or air के particles भी आगे पीछे move करते हैं. and that way sound travels आगे को, ठीक है? So this thing is basically sound wave, and the wave is traveling in parallel to the movement of particles. The other kind of wave is transverse wave, and transverse wave is different from this one because what happens is that this particle goes up, and that way it pushes this one to also go up, and that pushes this one to also go up, and this one, by the way, is going down for some reason. So now the particles are going to go like this. So particles इस तरह से move करते हैं और हमारे पास ऐसे wave बन जाती है. So particles are going up and down. लेकिन how is the wave going? So wave is going forward. So particles ये ऊपर जाएगा, ये ऊपर से नीचे आ जाएगा, ये भी ऊपर जाएगा, ऊपर से नीचे आ जाएगा, ये ऊपर तक जाएगा, ये भी ऊपर तक जाएगा, नीचे आ जाएगा. That way it keeps on happening, ठीक है? But the wave is traveling towards the forward direction. So energy is still traveling in the forward direction. So here the movement of particle वो ऊपर नीचे को है, or direction of energy forward को है. So they are perpendicular. So particle moves perpendicularly to energy, and this is called a transverse move. So इसी example है आपके पास all electromagnetic waves, they are all transverse. ठीक है? Because the movement of those photons is perpendicular to the movement of energy travel. Similarly, water waves, they can be longitudinal, but usually they are transverse. तो वो हमारे पास इस तरह से मूव करती हैं. तो आपने देखा होगा कि वेव जी ऐसे जा रही है. This thing can be generalized to all kinds of waves. So it doesn't have to be just transverse wave. It can be for the longitudinal wave as well. So अभी हम उसको देखते हैं कि वो ऐसा कैसे होता है. But the main idea over here is the first of all, particles travel and they just move, but they don't go all the way, but they transmit energy, and that's a wave. If you need a medium and the source is moving, then it's a mechanical wave. If you don't necessarily need a medium and the source doesn't have to move, then it's an electromagnetic wave. In electromagnetic wave, speed is fixed for the medium and frequency is inversely related to wavelength. In mechanical waves, speed depends on the density and the nature of the medium, but it's the frequency that is fixed. In electromagnetic waves, speed is fixed. In mechanical waves, frequency is fixed because frequency depends on the source. तो कितना vibrate कर रहा है. Two kinds of movement, two kinds of waves. So if the movement is parallel to where the energy is going, that's longitudinal, and sound is an example. If the movement is perpendicular to where the energy is going, then that is transverse, and water is an example, water waves. Now, we use many different terms to describe what waves are. So here's a pretty standard diagram of a wave. So if you look at this one, so there are a few terms here. So first of all, this thing, the dotted line in the middle, that is my rest position. Okay, so that is where particles were initially before the disturbance came along. So this is the undisturbed position. ठीक है, ये पूरी line middle वाली. तो particles move कर रहे हैं, and right now you can see that, for example, A particle is moving down, B is moving up, C is moving down, D is going up, but the wave is going forward. Now, how far do they come from the rest position? That is called their displacement. So for example, if I look at, let's suppose a point here, then this is going this much, so इसकी displacement इतनी है. If I look at this point here, so इसकी displacement इतनी है. But if you notice this point here, it is at the maximum disturbance, और उसको हम कहते हैं amplitude. It is the maximum displacement from undisturbed position. ठीक है, तो अगर आप वेव को ज्यादा एनर्जी देते हो तो इट इज पॉसिबल कि उसका एम्पलीट्यूड इंक्रीज कर जाएगा. सो फॉर एग्जांपल, इफ यू आर लिसनिंग टू म्यूजिक एंड यू सडनली increase the volume, then you're getting the same music, but now it's louder, and that means it has a higher amplitude. So it's the amplitude has been increased, and that feels like the volume is higher. It's delivering more energy without having any other change to the wave. So that's the amplitude. Another thing that it depends on is the intensity of a wave. So intensity or amplitude आपस में related. The second thing is, because we know wave is repetitive by nature, so wave will always repeat. So for example, if you look at this point A, so it is at the undisturbed position, it has this zero displacement, B has zero displacement, C has zero displacement, D has zero displacement. So they all have the same displacement, but A is going down and B is going up. So we will say that because A and B have opposite direction, in waves we call this direction phase. So uski direction opposite hai, so we'll say they are out of phase. But A and C have same direction, right? So we'll say they are in phase. So the idea of direction in waves comes from the idea, we call it phase. तो अगर बिल्कुल ही ऑपोजिट है तो वो entirely out of phase है, और अगर वो बिल्कुल ही एक जैसा है तो वो in phase है. But obviously it does include कि वो कितना दूर है. So for example, if there is a particle here that's going up, so this particle and this D, they are both slightly in phase, but not entirely in phase. क्यों? D की displacement zero है और इसकी displacement zero नहीं है, right? So displacement का फर्क जरूर है, but the direction is same, so they are slightly in phase. But A and C are entirely in phase क्योंकि उनकी डायरेक्शन भी एक है, उनकी डिस्प्लेसमेंट भी एक है. अब मुझे कैसे पता कि इसकी डायरेक्शन क्या है? So for that, remember one rule: particles follow particles behind them. This is a very interesting rule of waves. So for example, if I have a particle here and if I have a particle here, अब पता क्या होगा? Right now, this particle is going to follow this particle. तो अगर मैं इसको कह देता हूँ F और इसको कह देता हूँ E. So F looks at E and E is upwards, right? So F will try to follow that. E looks at the point behind it, let's call that G. So E will also go up. G ऐसे है, वो B को फॉलो कर रहा है, B के पीछे वाला उसको फॉलो कर रहा है, और वो ऐसे चलते जा रहा है. ठीक है? अच्छा, अब इस पार्टिकल को देखो. It looks at the point behind it और वो नीचे है, तो ये पार्टिकल नीचे को जाना चाहता है, ये और नीचे को जाना चाहता है, ये भी नीचे को जाना चाहता है, क्योंकि इसके पीछे वाला नीचे को है. And that is how the particles are moving. They always follow the point behind them. तो अगर आप इसको देखोगे तो इसका पॉइंट पीछे को है, तो ये पीछे को जाएगा. इसका नीचे है इससे, तो ये नीचे को जाएगा. इसके पीछे वाला पॉइंट इससे नीचे है, तो ये नीचे को जाएगा. So the direction keeps on changing like that. And C is going down. C के पीछे वाला ये वाला C को देखता है, वो नीचे जाता है. ये वाला उससे पीछे वाले को देखता है, ये नीचे जाता है. So this way the particles move. They always follow the position of the particle behind them. And that's a very interesting point, because that is how the wave travels forward. So wave आगे को जा रही है, हर particle अपने से पीछे वाले particle की position पे जाना चाहता है. And that is how the wave goes. ठीक है? So this is a very interesting and very important rule to remember. अच्छा, तो अब हमें पता चल गया कि particles कैसे move करते हैं, wave कैसे move करती है. अब हम थोड़े से और terms को देखते हैं. Why do they change direction at one point? Because उनकी displacement जहां पर zero हो जाती है, displacement maximum हो जाती है, वहां से दूर वो जा नहीं सकते. So at the amplitude they always change direction. Because उससे ऊपर तो वो जा नहीं सकते, उससे नीचे तो वो जा नहीं सकते. अच्छा, if you look at any 2 points in phase, so अगर मैं, let me just erase these blue lines. So if you look at any 2 particles that are in phase, so for example, if you look at B and D, they are exactly in phase. So the distance between 2 points that are in phase is lambda. This is the symbol lambda, this one, and this is basically wavelength. Wavelength क्या बताती है हमें कि how far are the 2 points in phase? Why is that important? Because the wave, a complete wave exists between 2 points in phase. And that's another very interesting point about the wave. a complete wave exists between 2 points in phase, and I'm talking about 2 consecutive points in phase. Okay, so B and D के बीच में पूरी की पूरी वेव एग्जिस्ट करती है. हर तरह का पार्टिकल, हर तरह के फेज वाला पार्टिकल, हर तरह के डिस्प्लेसमेंट वाला पार्टिकल बीच में एग्जिस्ट करता है. अगर आप ए और सी को देखो तो उनके बीच में भी ऐसी है. अच्छा, they don't have to be at zero displacement. Let's suppose I pick a point here. So this is at this one displacement and it is going up, क्योंकि इसके पीछे वाला is going up. So I look for another point that is at this displacement. तो ये मिलता है मुझे और ये मिलता है मुझे. So this particle and this particle. Where is this particle going? इसके पीछे वाला इसके नीचे है तो ये नीचे को जा रहा है. इसके पीछे वाला इसके ऊपर है तो ये ऊपर को जा रहा है. So right now I can see that this particle and this particle, they are in phase. तो इनके बीच में पूरी वेव एग्जिस्ट करती है. मतलब अगर मुझे ये पार्टिकल ऐसे मिले हैं तो ये ऐसे करके है, ठीक है, ये वेवलेंथ बनती है उसकी. नाउ इफ आई ट्राई टू कॉपी दिस पोर्शन, ठीक है, और इसको मैं इसके आगे जोड़ दूं, सॉरी, इसके आगे इसको जोड़ दूं, तो यू विल सी कि पूरी वेव दोबारा बन रही है. इसके आगे इसको जोड़ दूं तो ये पूरी वेव दोबारा बन रही है. उसके आगे उसको जोड़ दूं तो पूरी वेव दोबारा बन रही है. राइट? सो व्हाट्स हैपनिंग? You have found 2 points in phase that are entirely in phase, और उनके बीच में पूरी wave exist करती है. Pick any 2 points on the wave that are in phase, और उसके लिए आपने क्या देखना है? It should be at the same displacement and it should be moving in the same direction. अगर आपको वो points मिल जाते हैं तो वो entirely in phase है. अब आपने in phase points से करना क्या? The distance between 2 points in phase, उसको हम कहते हैं wavelength. So lambda, this thing, जिसको हम wavelength कहते हैं, this is the distance between 2 consecutive points in phase. Okay, and by in phase I mean they have the same direction, they have the same displacement. And the t, capital T, जिसको हम time period कहते हैं या खाली period भी बोलते हैं, this is the time taken for wave to travel from one point to next point in phase. तो जितनी जल्दी आपकी वेव वहां से वहां तक पहुंचेगी वो टाइम है, और जितना डिस्टेंस ट्रैवल करेगी वो वेव लेंथ है. तो इसका मतलब हुआ कि 2 पॉइंट्स इन फेज के बीच में पूरी वेव एग्जिस्ट करती है. तो पूरी वेव की लेंथ हो गई लैम्डा, पूरी वेव का टाइम पीरियड हो गया टी, तो लैम्डा डिस्टेंस डिवाइडेड बाय टाइम मिल गया मुझे स्पीड. तो स्पीड इज लैम्डा ओवर टी. राइट? अच्छा, एक और बड़ी मजे की बात है, देयर इज अ थिंग कॉल्ड फ्रीक्वेंसी, स्मॉल एफ भी बोलते हैं. एंड इन सीनियर लेवल क्लासेस लाइक आफ्टर, आई डोंट नो, ए लेवल्स में इट डिपेंड्स ऑन व्हाट, लाइक इफ यू यूज कैम्ब्रिज सीआईईस तो तब आपको एफ यूज करना होता है, बट इफ यू यूज अदर लाइक पियर्सन एंड ऑल दैट, एडएक्सएल, so then you use the symbol that is used in senior classes. In senior classes, like in university and all that, you use another symbol which is a weird V. This is called nu. So nu and f, they both mean the same thing, frequency. And frequency is number of waves, complete waves in fact, doesn't have to be complete wave. So number of waves per unit time. ठीक है? तो इसका मतलब है कि f is equal to 1 over t. तो ये मुझे फ्रीक्वेंसी की डेफिनेशन मिल गई. अब जरा देखना, I have one formula that is speed is equal to lambda over t, and I also know that frequency is equal to 1 over t. अब देखना जरा, this thing I can write as lambda times 1 over t, right? Because I can just separate them. And what is this 1 over t? It is frequency. So I can arrive at this idea that V equals f lambda. And that is the equation you need to remember for waves. So this one and this one, these are the 2 equations you need to remember for waves. Speed is f lambda. अब इसका फायदा क्या है? हाँ, why do you need to remember? So अगर आपके पास मैकेनिकल वेव है ना, तो उसका मतलब है फ्रीक्वेंसी फिक्स हो गई है, तो इसका मतलब है वेवलेंथ, स्पीड चेंज होगी, लैम्डा चेंज होगा, फ्रीक्वेंसी चेंज नहीं होगी. तो इसका मतलब है वेलोसिटी इज डायरेक्टली रिलेटेड टू लैम्डा इफ यू हैव मैकेनिकल वेव. और जो आपके पास इलेक्ट्रोमैग्नेटिक वेव है उसमें वेलोसिटी फिक्स हो जाती है. तो इसका मतलब है फ्रीक्वेंसी इज इनवर्सली रिलेटेड टू लैम्डा एंड दैट इज योर इलेक्ट्रोमैग्नेटिक वेव. ओके, सो इन इलेक्ट्रोमैग्नेटिक वेव frequency changes, wavelength changes, but speed doesn't. And in mechanical waves, velocity and lambda both of them change. So इसका मतलब क्या हुआ? Related है, directly related है. तो इसका मतलब है, अगर मैं आपसे कहता हूँ कि एक वेव जा रही थी पानी में, अब उस वेव की वेवलेंथ बढ़ गई है, तो यू नो राइट अवे कि उसकी स्पीड भी बढ़ गई, क्योंकि फ्रीक्वेंसी तो चेंज हो नहीं सकती, इट्स अ मैकेनिकल वेव. अच्छा, अगर मैं आपसे कहता हूँ कि रेड लाइट है, आई हैव रिड्यूस्ड इट्स फ्रीक्वेंसी, सो यू नो इट्स एन इलेक्ट्रोमैग्नेटिक वेव, राइट? सो इफ इट्स एन इलेक्ट्रोमैग्नेटिक वेव, अगर मैंने फ्रीक्वेंसी कम की तो वेवलेंथ बढ़ जाएगी. तो यू विल नो राइट अवे कि रेड लाइट जो है इसकी वेवलेंथ इंक्रीज करती, सही है? तो वो इंफ्रारेड में चली जाएगी, वो रेडियो वेव में चली जाएगी, वो जिधर भी मर्जी चली जाएगी, और हम उस पर बात करेंगे दोबारा. ओके, सो इन मैकेनिकल वेव्स velocity and lambda are directly related. In electromagnetic waves, frequency and lambda are inversely related. But the third thing remains unchanged. So that is the main difference between these waves. तो हमें वेव की एनाटॉमी पता लगी. अब कुछ खास टर्म्स यूज करते हैं हम लोग. So there is this term crest versus trough, and there's this term called compression and rarefaction. अच्छा, अब इनका फर्क क्या है? आपके पास अगर एक ट्रांसवर्स वेव है, तो ट्रांसवर्स वेव में पार्टिकल ऊपर जाता है, नीचे जाता है, ऐसे आता है. So this point, जब वो मैक्सिमम ऊपर चले गया, दिस इज कॉल्ड क्रेस्ट. एंड दिस पॉइंट वेयर वो मैक्सिमम नीचे चले गया, उसको कहते हैं ट्रफ. अच्छा, जो आपके पास लॉन्गिट्यूडनल वेव है ना, वो डिपेंड करती है पार्टिकल्स के फॉरवर्ड बैकवर्ड आने पे. So let's suppose I have particles shown like this. So this is a wave. वो पार्टिकल्स बहुत पास पास हैं, फिर वो दूर होते जा रहे हैं, मैक्सिमम दूर हो गए हैं, अब वो पास आते जा रहे हैं, फिर वो मैक्सिमम पास आ गए, फिर वो दूर होते जा रहे हैं. This thing, what's happening when the particles are really close to each other, that's called compression. When they're far apart from each other, like over here, that's called a rarefaction. So in longitudinal wave, एक compression और दूसरी compression के बीच में पूरी wave exist करती है, ठीक है? और ऐसे आएगी ना, in fact इन दोनों के बीच में a compression all the way to over here, that's a total wave. और इनके अंदर एक क्रेस्ट और दूसरे क्रेस्ट के बीच में पूरी वेव एग्जिस्ट करती है. तो यहाँ पे भी इनके बीच में पूरी वेव एग्जिस्ट करती है, इनके बीच में भी पूरी वेव. सो एक क्रेस्ट और दूसरा क्रेस्ट पूरी वेव एग्जिस्ट करती है, एक कंप्रेशन दूसरी कंप्रेशन पूरी वेव एग्जिस्ट करती है. आई डोंट नो व्हाई आई ड्रॉ द थर्ड वन, डिडंट रियली नीड टू. ठीक है, तो हमारे पास वेव आ गई. अच्छा, अब हमने क्या क्या टर्म्स बात की? वी टॉक्ड अबाउट वेवलेंथ. Wavelength is the distance between two crests. Wavelength is the distance between two troughs. Wavelength is the distance between two compressions. Wavelength is the distance between two rarefactions. Wavelength is the distance between any 2 points in phase. बहुत सारे तरीके हैं wavelength को डिस्कस करने के, but it's a distance. Frequency is the number of waves per second या per unit time. ठीक है, तो जितनी ज्यादा waves pass कर रही हैं उतनी ज्यादा आपकी frequency होगी. Speed is the distance that the wave has traveled, so the wavelength divided by the time that it has taken to do that. So it is v is equal to f lambda. Amplitude is the maximum displacement of a point in a wave. और आप ये भी कह सकते हो कि amplitude is the height of crest. आप ये भी कह सकते हो amplitude is the depth of trough. ठीक है, वो भी आप कह सकते हो. अच्छा, phase क्या है? Phase is when the particles have the same direction and same displacement, so that means they are in phase. ठीक हो गया, तो हमारे पास वेव का हमें पता चल गया. अच्छा, अब यहाँ पे एक और चीज देखें. I told you that I can have all these waves following each other, right? So if I look at this point, this crest and another crest and another crest, so all of these crests are in phase, right? So let's say I draw an imaginary line that passes through all the crests. Then I draw an imaginary line that passes through all the troughs. I draw another imaginary line that passes through all these points जो कि in phase है. तो ये point in phase है, ये point in phase है, ये point in phase है, ये point in phase है. मैं इनके बीच में एक imaginary line draw कर देता हूँ. If I keep on doing that, this imaginary line is called wave front. क्योंकि when you look at a wave you don't see every point. मतलब वाटर वेव आपके पास आ रही है तो आपको हर पॉइंट उसका मूव करता नजर नहीं आएगा, आपको वो वेव का पूरा वेव फ्रंट मूव करता नजर आएगा. तो इफ यू लुक एट वाटर वेव, तो वाटर वेव्स किस तरह से होती हैं? सो फॉर एग्जांपल दिस इज अ वाटर वेव, ठीक है, ये एक वाटर वेव, ठीक है. सो दिस थिंग ओवर हियर, दिस इज नॉट अ कंप्लीट वेव जो आपको नजर आ रही है. व्हाट यू आर एक्चुअली सीइंग इज अ वेव फ्रंट, ठीक है. आपको उसके सारे क्रेस्ट इकट्ठे नजर आ रहे हैं. ये जो टॉप नजर आ रहा है ना आपको, ये जो वाइट सी लाइन है ऊपर, और ये भी एक लाइन है, ये भी एक लाइन, ये क्या बता रही है मुझे कि ये, होल्ड ऑन, ये एक क्रेस्ट है, ये उसके अगला 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 क्रेस्ट है, ये उसके पिछला क्रेस्ट है. ये बेसिकली सारे मेरे पास वेव फ्रंट्स नजर आ रहे हैं. देयर ऑल द क्रेस्ट, और वो मुझे नजर आ रहे हैं. और इनके दरमियान का जो डिस्टेंस होगा ये मेरा लैम्डा होगा, बिकॉज डिस्टेंस बिटवीन टू क्रेस्ट इज लैम्डा, वेवलेंथ. तो मुझे असल में जब वेव्स नजर आती हैं, फॉर एग्जांपल इफ यू लुक एट, if you're flying and you look at water waves below you, so you will see them as wave fronts. You will not see individual wave ऐसे घूमती हुई. और ये सारे के सारे wave fronts आपको इस तरह से नजर आएंगे. And the distance between two wave fronts is your wavelength. ठीक है. तो waves हमें usually इस तरह से नजर आते हैं. So for example, this is another wave. अब जी जरा देखना इसमें. Over here, this is deep. This is shallow. अब आप देखना जरा. In shallow, the waves are closer together and they are faster. Okay. But in the deeper part, the waves are further away. क्यों बोला? क्योंकि in shallow portion waves की wavelength कम चलेगी और deep में wavelength ज़्यादा हो जाती है. And you know these are mechanical waves. तो velocity is directly related to lambda. तो अगर lambda ज़्यादा हुआ है तो wave की वेलोसिटी भी ज्यादा होगी, और अगर शैलो में वेवलेंथ कम हुई तो वेव की वेलोसिटी भी कम होगी. ठीक है. एंड दैट इज व्हाई यू कैन सेफली गो टू द बीच. सो आप बीच पे हो और लेट्स सपोज ये सी है और ये समुंदर का पानी है. ठीक है. लेट्स गिव इट अ कलर. ओके ओके, व्हाई इज द कलर गोइंग अवे? ओके, वियर्ड. Anyways, wait a minute. Let me try another color. Okay, wow. Fair. So you have, so somebody standing over here. This person sees a wave coming. So there's a wave that's coming. Yes, a wave aa rahi hai. This wave will literally destroy the person. But when, so this wave has a really fast speed and really big wavelength. ठीक है. बट व्हेन द वेव कम्स क्लोज टू द शोर, तो वो उसकी वेवलेंथ कम हो जाती है. और जब वेवलेंथ कम हो जाती है तो वेलोसिटी भी कम हो जाती है. तो ये बंदा बैठा एंजॉय कर रहा है वहां पर, क्योंकि द सेम वेव दैट हैड अ हाई स्पीड एंड लार्ज वेवलेंथ, व्हेन इट ट्रैवल्ड ऑल द वे ओवर हियर, सो इट हैज अ स्मॉलर वेवलेंथ and lower speed. Slow हो गई है wave. But what did not change was frequency remains the same. ठीक है. तो वो बहुत मजे से enjoy कर रहा है. But the same person if they try to come over here, so उनके साथ वही होगा जो टाइटैनिक में होता. Why? Because these waves are going to be huge. The same waves which are very gentle in the shallow portion are now huge. And it's not because waves have changed. It's just that they needed to maintain the same frequency, क्योंकि सोर्स उनका सेम था. इस वजह से उनकी वेवलेंथ बढ़ गई है. वेवलेंथ बढ़ गई मतलब आपने ज्यादा डिस्टेंस ट्रैवल करना है तो ऑब्वियसली आपको तेज जाना पड़ेगा ना, अगर आपने उतने टाइम में करना है. द डोर हैड मोर देन इनफ स्पेस. या सारा मसला स्पेस का ही तो है. एवरीबॉडी नीड्स मोर स्पेस. ओके, सो नाउ यू गेट इट दैट वेव्स कैन बी डेंजरस इन ओपन वाटर और डीप वाटर कंपेयर टू द सेम वेव्स इन शैलो वाटर. ठीक है. इसलिए हमें मतलब दैट्स समथिंग यू नीड टू नो अबाउट. अच्छा, तो वेव का हमें पता चल गया कि वेव्स किस तरह से होती हैं, क्या उनकी एनाटॉमी है एंड ऑल दैट. सो we'll resume our session from here in the next class. We'll talk about what waves do. So we'll talk about reflections. We'll talk about when waves bend. We'll talk about when waves turn, what happens there. And for that, it's very important that you vocabulary apni build kar lein. So you have to understand what wavefront is, what frequency, lambda, wavelengths. We will talk about these terms. So you need to be very clear on the concept of these. So do read the book. Book is really good. आप उसको पढ़ो.